there is a new player entering the world of digital FPV, and that is this. The T3 digital FPV system from a company called Edge Smart Drive. Now, both the system as well as the company are new to FPV, and when this first landed, it got an incredible amount of interest. Many people, including myself, were wondering, what is this? Is it like DJI and Avatar, which is SDR LTE WiMAX based? Is it like OpenIPC Ruby FPV? Is it Wi-Fi based? And we've learned a huge amount about this system over the last few weeks and months as it has started to get into people's hands. I can confirm up front that this system is actually based on Wi-Fi, but it is doing things differently to the likes of OpenIPC Ruby FPV, the RunCam Link and others, because whilst it is using Wi-Fi based hardware, it is closed source software. It is not open source. It is not a copy of OpenIPC. And what it is something different to anything else that we've got out there. So today, what I'm going to do is give you a complete overview of this system from my perspective. I'm going to walk you through its features, its capabilities. We're going to get it in the air. We're going to tear it down. I'm going to go through everything. And at the very end, I'm going to share with you my thoughts. Now, just to be clear before we get into it, this system was sent to me by Edge Smart Drive for free. However, they have not paid me to make this video. They've not seen this video before it's been published. And as always, my thoughts are entirely my own. Okay, so the T3 is a digital FPV system which consists of a VRX module for your ground station and a VTX module for your airside. Now, the kit they sent me comes in this all-in-one box. It's actually two separate boxes inside, but they have this outside sleeve that holds it all together. You can see they have some of their marketing stuff on here. So you've got AI imaging, 35 kilometers maximum range, 120 megabits a second, USB-C. We're going to be taking a look at these claims later on because some of these I think are definitely rather bold, is the term I'll use, but we'll talk about that as we move through the video. Now, as for the price of this system, it is available from their website in the following options. You can get the full kit, which is the air unit and the ground station. That is being sold for $329. You can get the ground station for $189 and then the VTX for $140. At the moment, at the point of me recording this, all of this is out of stock, but $329 is the price for the full kit as you're seeing it here today. Now, I'm not going to do an unboxing in this one, but what I am going to show you is in here, you then have each individual box because you can buy these separately. So you got the T3 VRX and then you got the T3 air unit. Rather than doing a complete unboxing of these, I'm going to show you what you get in each one and then move on to the product itself. When it comes to the VRX module, you obviously have the VRX module itself. In the kit with that, you also have this LAN cable, and then we have this other set of cables. Not exactly sure 100% what they're for. They are looking like they're for the UART input on this, the RC control input. Again, some of the stuff we'll talk about later. When it comes to the VTX, things are very similar. In the box for that, you get the actual VTX module itself. Comes pre-wired with the antennas connected and our camera module. And then it also includes a little bag with cables for connecting our flight controller to our VTX. Also in the boxes, you will find little leaflets with various pieces of information on. So for instance, for the VTX, you can see we've got a quick start guide. This shows us all of the IO connections down here, as well as some status information about the product and IO connectivity as well. Now, starting with the ground-based module, this is a bit different to the modules that we've seen from other manufacturers. It's not really designed to be attached to goggles. It's designed to be used as a fixed ground station that you can plug your goggles or your display devices into. Looking around it, it comes with these two patch antennas on the top that are removable. We'll take them off and have a look at them in a minute. On the front, you can see we've got a blank panel with a fan. On this side here, there is a USB-C connection, as well as a power button, menu button, and select button. You then on this side have another USB-C connector and a couple of other connectors there, which we'll look at in a bit more detail. Now, you'll notice that there is no HDMI out on this unit. It does, though, support HDMI with a USB-C to HDMI adapter. This USB port is designed to power and charge the device. There is a small built-in battery on this, which means you don't actually have to plug it into power to use it. If you charge that battery, you can just use it as you see it here. That port, though, will only provide power. This port on this side will provide video output via USB-C, and you can use a USB-C to HDMI adapter to attach it either to a display or a set of FPV goggles. Looking around the module in a bit more detail, you can see we have two RP SMA connectors for our antennas. There now you can see that USB-C port and our buttons for our menu and control. Basically, the bottom button acts as power and selection, and then the top button is basically like a select button. And then on this side, you've got the other USB-C as well as two additional I/O ports. These ports consist of a Ethernet port, which is the first one here, and then you have an I/O port which has S-bus output, servo power, and a serial port. As I mentioned earlier, this USB-C port is the display output. It supports both USB-C to USB-C displays or USB-C to HDMI, and it will output 1080p 60 frames a second. Moving over to the included antennas, you can see that we've got two patches. These are 50 ohm patch antennas. They don't provide any great detail with regards to the specification of these. They simply say that they are 5G directional antennas. There is no gain specification that I have seen. They are linked together. I guess you could unlink them if you wanted to. It is perforated in the middle, so if you did want to separate them, you probably could. However, I'm not going to do that here today. What we will do, though, is get them on the VNA a little bit later to take a look at how they perform. Next, moving over to our VTX module and camera. Now, this VTX will look quite familiar. It is very similar in shape and design to the original HD0 Freestyle VTX, the version 1, not the version 2, and the original Avatar VTXs. Now, this is obviously designed to be used just with their ground station. The VTX has two antenna ports that you can see there. There are two UFLs located underneath there, so they do include little left-hand circular polarized antennas with it, but you could replace them if you wanted to. The camera connection is a MIPI connector, pretty standard, and that's including the cable that goes up to the camera there. And then you will also note on the side of the VTX there is an SD card slot. The SD card does stick out a little bit at the side for the airside DVR. Then, looking around, we have a bind button, and then we've got our I/O ports on this side here, as well as our I/O over here. Now, this first port that you see here is the power port. This is basically the same connection as DJI use. So you can actually connect this to your flight controller with the DJI O3 and O4 compatible cable. This has all of the usual wiring, so it supports S-bus, it supports the UART as well as the power connections. This system does allow you to pass your RC signal over the system if you want to. We'll talk about that, though, a little bit more later on. Next to this, we then also have a little 4-port connector, and that is our Ethernet port. As I mentioned earlier, this system supports Ethernet, and what that basically is Ethernet tunneling. It will allow you to connect an Ethernet device to either side and pass that information over. Now, this isn't anything particularly special. We have seen other systems with this before. For instance, HureLink supports Ethernet. Many of the CE systems also support Ethernet as well. It's not particularly common in generic FPV like DJI, Avatar HD, but when it comes to anything that's designed to be carrying bigger payloads and cameras, things like the CE system, HureLink, Ethernet is pretty much the norm. There are many digital cameras now that support Ethernet output, and that will work with this system, and they do actually have their own cameras apparently coming for this as well. Then moving over to this side, you'll see another connector. This is an I/O connector. This has a USB connection. It has ground, servo power 5 volts, and it also has a servo output as well, so it supports yaw and pitch control, allowing you to have head tracking directly from that connector there. Looking around the VTX, it is an external metal housing, aluminium, and on the top you can see there's a little built-in heatsink there. When it comes to size, you are talking a depth of 11.77, and then if we talk about width, we are talking 37, and if I do the VTX, 36. However, if you do take into account the SD card, you're talking 38.2. Moving over to the camera, they say it is powered by Sony's latest Starvis 2 sensor. We believe this is going to be using the Sony IMX662. That is the sensor we believe is based into this system, and they say in the marketing information that it delivers 8 times wider dynamic range. Now, at this point, I want to add a pause because newer information has come to light that actually suggests that this isn't a Starvis 2 sensor and instead is the IMX307, of which there are also drivers for in the system, which is a Sony Starvis sensor, but it's not a Starvis 2 sensor. Now, this information has come from some of the reverse engineering of the system, and as a result of that, it would imply that the marketing material isn't quite correct. However, we will come on to that subject later in the video. Now, it is quite a big camera. Size-wise, it's a bit of an unusual fit because it's not 19mm wide and it's not 20mm wide. In my checks, my camera basically comes in at 19.5. You can see there 19.61. If I squeeze it in tight, we get it down to 19.48, 19.5. So it does sit between the two. And with regards to depth, it's coming in at 30.5 mil. It does have 2 mounting posts built in. For some reason, they seem to have followed DJI's approach by having this strange mounting pattern setup rather than the one that you find traditionally. And it does then have a hardwired MIPI cable in the back that heads off to our VTX. As I mentioned, with regards to recording, there is a DVR built into the ear unit, but as far as I can tell, there is no recording on the ground side. There is no SD card slots on this. It does have some built-in memory, so in theory it could be recording locally on board and you might be able to access that via USB, but that isn't something I've been able to do so far. So the only recording that I have found so far is on the ear side itself. Whether that is something that might change in the future, I don't know, but what there isn't is an SD card on this, so if you are going to want to record on the ground side, you're going to need to record via that USB/HDMI output. When it comes to the RF link on the T3 system, there are a few things that you need to be aware of. I'm actually going to talk about this subject in a bigger separate video in the near future where we're going to talk about the real differences between the likes of DJI, Avatar HD, this and others. But I also want to make sure in this video you understand how this differs from what DJI and Avatar HD are doing. This system is based off Wi-Fi. It is using Wi-Fi hardware, it is using Wi-Fi at the PHY level, which is the hardware level, and it is basically using a modified Mac level driver to communicate over Wi-Fi. This is basically the same as OpenIPC. It's not OpenIPC software, but it is the same implementation. You are taking off-the-shelf Wi-Fi hardware. That hardware has fixed functionality that you cannot change, but you then have driver level functionality that you can modify, but that does mean it is still a Wi-Fi based link. It is not a completely customized link like DJI or the likes of the Avatar HD system are using. It is still rooted in base Wi-Fi specifications, and whilst it won't conform to any of the usual Wi-Fi specs, so you're not going to pick this up on Wireshark or anything like that. At the end of the day, it is still using Wi-Fi hardware, and it still is bound by the limitations that Wi-Fi hardware gives. One of the simple analogies to this is a pipeline and its contents. DJI and Avatar HD are able to completely design the pipe, the shape, the size, and choose what they pump through it, whereas this system is using the same pipeline as Wi-Fi, and they are simply able to modify the information that they are sending over it. The overall link, though, is still dictated by the main core Wi-Fi chipset. There is a lot more complexity to it than that, but the very basics are it is using fixed functionality hardware, and then they're having to modify the drivers to allow it to do some stuff around that. Now, you can see some of this in the main menu system. If we go into the main menu by pressing the power, the top option we have is frequency select. If we go into this, it gives us two options, 5G or exit, so it's 5 gigs. The system only runs on 5 gigahertz. There is no 2.4 gigahertz option at the moment. It is a bi-directional system, and we'll talk about that a bit more when we have a look at it on the spectrum analyzer. Under here, you can then select the frequency selection. So you've got frequencies such as 5885. Some of these numbers are quite familiar for the Wi-Fi side of things, but you can then go all the way down to 54, 53, 52, down to 5180 minimum, and you can choose whatever frequency you want from that list. Stepping backwards, we then have the transmitter power options. Now, this is laid out a little bit weirdly because they've separated it into blocks. You've got the power at block 5150 to 5250, then you've got the block at the next level, the next level, the next level. We're currently on 5885, so if we wanted to select that block, we will go down to there, and there you can actually see we have the power options available. Now, I will talk about these actual numbers a little bit more later on with regards to, is it really delivering what they're saying there is 2000 milliwatts, 2 watts. It's very hard to measure RF power, and the way this system actually behaves basically means, as far as I'm concerned, you can't measure it, and I'll explain why later. But from a power option perspective, you have from 20 milliwatts all the way up to that 2000 milliwatts. If I then go back, you can then select some of the other options. It's a bit strange how they've laid this out into different sections. One isn't for receive and one isn't for transmit. All of these power options are for the VTX. So you've got it here for 5.1 to 5.250. If we go down to the next one, they're each replicated under each section of the 5 gig frequency band. Next, going down to air unit, here you have options for the power settings. So you can select the cell type, so what your battery type is. This is for the on-screen battery readout. You can select the cells, and then we also have camera options available as well. Under here, you've got options for the electronic filter, ultra starlight, indoor flicker, so anti-flicker, color mode, EV compensation. If we go back, we've then got our remote controller settings. This system does allow you to pass RC link over it from the ground station up to the air side, and you've then also got the options around the head tracking features that are built in. As I mentioned earlier, it does have that servo output directly on the VTX, which allows you to directly control servos or control a gimbal that via those outputs as well. And then you've got the settings for this here. Now, with regards to OSD on this system, there are options in the menu, which we'll look at in a second, but this is the main OSD that you can see here. This system does support MAVLink and MSP, but it isn't MSP DisplayPort. It takes the MSP data, but it overlays its own OSD. This is basically the same as what DJI used to do in their original FPV system. You can see on the screen, if you look around, you've got icons. So we've got battery level, you've got mode, throttle. You can turn all of these on and off in the menu. Top right, you've got your signal information, your frequency information, as well as the bit rate, which is currently saying 120 megabits a second. We'll talk about that a bit more later on. but it is an OSD. You can change all of this. So if we go into the menu, and go down to the UI layout, under here you've got multiple different configuration options for the UI available, so you can save multiple different profiles. You've then got the options for each of the OSD icons. So if I just go into the 5 gig frequency one a second, you've got the option to adjust the value, but you can also do things like change the position as well as the type as well. So if you see there, I can scroll through and it will change the kind of icon that it's using for that. So I'm going to go back to number 8, which is that one there. You can turn it on and off, so you can see in the top right that that is now vanishing. And then you've got your exit. Now, obviously, you have options for this under each one. So you've got all of these different options available to you. But again, this isn't MSP DisplayPort. It is just a customized OSD. Next, we then have things such as language selection, so you can select English or Chinese. Then we've got our version information for the firmware, our country selection, which currently is fixed to unspecified. Then the bottom option is exit. Now here you can see the image from the system on the screen. We're going to talk about that side a lot more when we get it into the air. But as you can see, it does have that OSD. If I just move my flight controller, you can see this. Really, this is geared towards fixed wing long range quads. What this isn't, though, is going to give you that MSP DisplayPort like you get on the likes of the Avatar and now the DJI systems. Taking a look at the T3 system on my spectrum analyzer and talking about it a bit more from an RF perspective, the first thing I can confirm is this system is a bi-directional link. So the transmitter is transmitting video back down to the receiver, and the receiver is transmitting back up to the transmitter. This carrier you are seeing here is the video carrier from the transmitter at the moment. If I just turn on Quasi Peak, you can see it a bit easier. The carrier bandwidth that I have seen on this system is 20 megahertz. I've seen no other bandwidth available on the system. If we just measure it with some guard interval as well, you can see, yeah, if we sort of go from there to there, we're getting 20 megahertz. The actual peak carrier is about 18, but 20 megahertz with guarding on either side. There is no variable bandwidth that I have seen on this system. I've not seen 40 megahertz. I've not seen 10 megahertz or anything else. It very much appears to be fixed 20 megahertz bandwidth. As this system is loosely based on Wi-Fi, it does behave a lot like Wi-Fi from an RF perspective. With regards to the carrier, the actual power depends on the link saturation. It is variable, so it isn't showing all of the power here on the bench. You actually have to get the system to separate out before it starts showing the full RF power, but it is also dependent on link saturation as well, i.e. how much data is moving through the link. For instance, if I just grab the camera here and move my finger over it, you will slightly see, if I block it, it's hard to show here because it's right next to it, but as I'm tapping, you can see the carrier move. If you actually put a bit of separation in between this and this, you actually start to see the variability of the power in a bit more detail. Now, just to try and demonstrate this variable RF power, my VTX is in a fixed position and my VRX module is, as I speak, starting to move away further and further from the VTX. What you will start to see as this happens, the carrier actually increase in amplitude and increase in RF power. It'll take a bit of time because I've currently got it set on the maximum setting, but there you go. You can start to see it increase the further away from the VTX it goes, and you're even now starting to see the yellow average power bar appear because it's kicking that RF power up. If I start moving the image on the camera as well, if I wave my hand in front of it, 1 second, I actually moved the antenna then, which was not what I wanted to do. If I now start moving my hand in front of the camera, you can see it actually affects the RF power that is coming from the VTX. So it relies on both the distance between the VTX and the VRX module, but also is dependent on the amount of data that is moving through the link. This is very much typical Wi-Fi behavior. Now, just to show you the difference between the transmission on the VTX that you're seeing here and the VRX module, we're going to move my input across now over to the VRX module, and you can now see there that carrier has changed. Again, 20 megahertz carrier on exactly the same frequency as the downlink. Basically, bidirectional link, 20 megahertz up and down on the same frequency, depending on what you've obviously set it to in the menu. Just to also prove to you that the RF power settings do work, here we've got the menu up in the corner. We're going to go into the main settings. We're currently on the minimum setting at the moment, which is 25 milliwatts. We're going to go all the way down to the maximum setting. We'll set it to that. Hit OK. And if you now watch the carrier on the screen, boom, it's changed and the RF output has increased. So that, again, not only proves that it is a bidirectional link because it's communicating between the two, but it also does actually increase the RF power as well. Now, just to show you what the system does when it's powered down, at the moment we only have the VRX module powered on. This does transmit all of the time. You can see there a very faint carrier showing. This is because there is no data, no saturation over the link. If I turn on quasi peak, so there you can see that there is a very faint carrier from the receiver module when the VTX is powered down, but it is basically a pulsing carrier with no data going through it on the frequency that has been selected. From the VTX, when the VRX module is turned off, there is also a slow pulsing carrier pretty much across the whole 5.4 to 5.8 gigahertz band. Here you can see it will pulse across periodically. There you can see the carrier come across and then vanish. It's a very fast pulsing carrier. It is something to be aware of. It isn't particularly normal to have a situation where your VTX is going to be left on without your VRX module, but it is something that I spotted that I did just want to show, but it isn't anything I would expect to cause any problems. Okay, now the next thing I want to talk about is latency, because I've done my usual suite of latency tests on the T3 system, and whilst there is nothing here particularly surprising, I do want to walk you through the results. Now, before I walk you through the numbers, I do just want to explain a few things. These latency tests were done on a set of HD0 goggles with the very latest firmware. That is the firmware that pretty much removes all of the input latency. Also, we used the same 1000 frames a second camera that I use for all of my latency testing. It is a direct apples for apples comparison compared to my previous latency testing, which we'll take a look at in a minute. It is also worth me adding that some of these results may look high compared to 60 frames a second on other systems. However, it is worth taking into account this, to me, wasn't really unexpected. This system has a USB-C output, and as you will see in my teardown, that is actually a conversion from HDMI internally. But what that means is we're also doing multiple conversions here before outputting the image to our display or goggles. For instance, internally it's output in HDMI, which is being converted into DisplayPort, which is then being reconverted back into HDMI to allow us to put it into our goggles. And as a result of that, the actual latency is going to be A, dependent on the display device that you're using, but B, we have that pipeline latency in the system as well. Now, taking a look at the results, our average first pixel is coming in at 67.7 milliseconds on 10 runs, and our average full frame is coming in at 86.7 milliseconds. Our lowest first pixel that I have seen is 59 milliseconds. That is the lowest latency that I have seen from the system, period. And whilst this is definitely higher than some other 60 frames a second systems, so for instance, HD0, it's dramatically higher, but even DJI and Avatar on 60 frames a second, it isn't completely unexpected to me based on the fact that it is Wi-Fi derived, and B, it has this multiple conversions going on internally with regards to the output. Next, moving over to my scatter chart. Now, this is just to give you a view of how wide a variance there was between each run on the first pixel and the full frame. So what this has is each individual run that has a different latency number. If the run had the same latency number, it's just going to be shown here. And in 10 tests, you can see that we had a variance from that lowest pixel latency, which is there, to that highest there. And then on the full frame, we had the same. Now, this isn't particularly terrible. There is a bit of a run-to-run variance, so that latency on the bench is moving each test. However, it's not as bad as we saw with the original Avatar HD system when that originally launched. That had a massive spectrum between the lowest and the highest in each individual test, which Caddx later fixed. I think it's what I would expect, but again, it is worth me mentioning that this is bench testing and not actual real world. This is best case scenario, and it's only going to get worse from here. Now, the final chart I just want to show you is my full latency test chart. Now, I currently don't have OpenIPC on this for a few technical reasons, because I do have latency results for OpenIPC, which come out around this area here. However, this is set up per manufacturer, not just as a system. As OpenIPC is based on multiple manufacturers, it's quite hard to put a specific place for it in. I'm going to add it, but I just need to tweak the chart a bit before we do it. Now, as for the T3 system, you can see that currently it's coming out over here on the right. It's currently coming out as the highest that I've tested from any off-the-shelf system. We would have expected a 60 frames a second system to be in this mid area here. You can see you've got DJI Goggles 203 here, which goes all the way down to the likes of Avatar HD 60 down here. So anything in this sort of range would have been normal 60 frames a second latency. Obviously, that's not compared to the likes of HD0, which is still one of the fastest systems available on the market, even though it is still 60 frames a second in its normal mode. The 90 mode is insane. We'll move on from that in this video. However, as I've shown, it should be in this area here, but with that penalty which I was talking about earlier, which may be related to the fact that it's Wi-Fi derived, system derived, and all of that conversion going on, we're coming out up here. The worst that I've tested so far. However, not particularly unexpected from my perspective. So the next thing we need to do is get this in the air and actually test it and demonstrate it and tell you what I think about it in flight. We're going to do some tests at the field first of all, and then we'll move down to the beach and I'll give you some thoughts as I have it in the air. Okay, so this is the very first flight with the T3 system. I'm recording the DVR that you're seeing on my HD0 goggles, so that means you will see what I will see through the lenses. Obviously, there might be a bit of a resolution difference, but overall, it'll be pretty much the same. Now, I've just actually been flying Ruby FPV on the RunCam VRX, so this is going to be a nice comparison between the two as well, which I'll talk about. So, let's arm, and let's see how this goes. I'm going to take it very easy for the first flight. Just scoot about the field and see what it feels, what it looks like. I have to say, instantly, I've noticed something. This instantly feels like any of the other normal FPV systems. If you've watched my other videos on OpenIPC and that Ruby FPV one, which we'll publish probably just before this one, I'm always noticing this sort of very step-in, not smooth, staggered effect to any yaw movements. This is perfect. This is normal. This is like DJI. This is like Avatar. Initially, this feels really like the DJI FPV version 1 system. Really like the V1 and Avatar. Wow. I am instantly surprised at how this feels. There is a lot of compression, blocking. You can see that, but it's smooth. Yeah, there's a lot of, yeah, it is very much blocking up on the grasses. Again, really reminds me of the V1 system, which is actually incredible considering this is Wi-Fi based, Wi-Fi derived. Sorry, I should be saying, not Wi-Fi based, Wi-Fi derived. This is not using an SDR. This is not using the same basebands or anything that you see on the other systems. Obviously, this is 60 frames a second, so we've got no low latency modes here. But I can't say I'm terribly... Yes, okay, yeah, the latency is high compared to, say, DJI and Avatar, but it's flyable. It is windy here today. I've got confidence. Ooh, that's smeared. Okay. Definitely likes to smear up on grass. I'm interested to have a look at how this looks in the beach on the high level. The real reason I do like to test fly at this field, these greens really push the codec. Like you saw that then, hopefully. It really pushes the codec, and so it gives you an indication of how the system is able to cope with a lot of high frequency detail information, which is grass, repeating detail. Oh yes, it struggles definitely. It actually looks better on the field, but when the codec then changed the image, so it's bringing in a different frame. So if I do that again, we'll come up over the top. What's my battery level like? 21.6. It's all right. I'm going to do it slowly. There, you can see that the compression is struggling to bring in the changes. It certainly isn't designed for racing, and I'd even argue it's really not for freestyle. Oh no. However, that's not to say it doesn't have a place in fixed wing, long range, or especially where there's no high frequency detail. Oh yeah, it really does not like that. How's it look on a loop? Oh yeah, handled that fine. I'm keeping the height up today. Yeah, getting a bit of jello. I have to say, oh yeah, it does compress up very. See there, now I'm at the low level, it's struggling, and I'm on maximum RF power here as well. Oh, oh, that was close. I couldn't actually see the grass. All I could see was that blanket of compression, and that's all I had in front of me. Oh, and I'd actually argue, yeah, it seems to be getting a bit worse. Take the height up, straight away cleans up. Okay, this battery's done. See, take the height up. That looks fine. Yep, okay, swap packs. Okay, so we're just going to do a quick second flight again. I've increased the camera angle a little bit just because of how windy it is here today. And then what we're going to do in a minute is head down the beach later today when the tide is low and just have a look at how it feels. Oh, that is replicatable every time. That change in scene with that compression. I'm just going to come around again and do exactly the same again one more time just to show it. That's just fully replicatable. So we've got the trees in view. We'll come down and, oh, mush. Oh, we're back to live. Okay, so let's push it out a little bit. It's so windy today. I'm even having trouble moving forward over here. There is a radio tower. Have to say, from a flying high perspective, it looks really good. You can see the test field. Everything looks fine. It's definitely struggling with low level. That's for sure. I think from a fixed wing perspective, there's a lot to like here. I think pricing becomes a different conversation, and we will talk about that in the video, because this isn't open source cheap Wi-Fi derived. This is Wi-Fi derived hardware with closed source software, and pricing is it's not in that open source territory. That's for sure. Oh, yeah. Ooh. I'm just going to do. Okay. What I'm looking at is how it's. Do you know what? Whatever they've done, this sets them apart from everything I've tried on Ruby and OpenIPC so far on the feel. The feel of this is perfect. Obviously latency, obviously compression, but the actual image delivery, bang on. Absolutely perfect for me. Not a problem. They have done something here that I have not seen in a Wi-Fi derived system myself yet. I'm not saying others haven't, because there's a lot of people who have got some really cool things happening with OpenIPC, Ruby FPV. They're flying them in 90 frames a second modes, getting really smooth images, racing type of scenarios with it. I'm not saying they are racing, but they are certainly banging it around. I've still not seen that kind of performance for myself. I've not seen this level of performance myself. I wonder if that is the hardware or is that the software? And this is really where it gets difficult to talk about, because, you know, is this a problem of the hardware isn't doing Ruby and OpenIPC justice, or is this a problem of both? Combination. Open source is really hard. Delivering a complete solution is not easy. Okay, so we're here with the T3 system, and let's take it for a flight. Now, this is more than anything just to give you an overview of how this looks down the beach in a bit of a sort of more fixed wing long range environment. We've seen what it looks like around the field. Here, I'm going to take it around for a scoot just to give you an idea of how it looks here. It is as it was this morning at the field, very, very windy. In fact, it's windier today here tonight than it was this morning. This is now late afternoon. This is to give you an indication really of how it looks. I can't go too far down there because my VRX module is only pointing forward, not that way. So let's head this way. We'll look at the high level first, and then we'll come in and have a look at the low level and see what it looks like. I have to say, from a high level perspective, this system looks really, really good. I really do like how it looks. It feels so much like the original DJI system, as I've just said. And actually, oh, it is blowing a gale. I have just finished flying the Ruby FPV system down here. I'm filming both of these videos today, and I've been flying back to back between the two systems. And it is night and day between how this feels and how that feels with regards to smoothness, image delivery. Now, I still don't understand those issues I'm facing on the OpenIPC Ruby FPV side, but what I can tell you is whatever these guys here are doing, they're giving a very nice, smooth experience with regards to the frame delivery, how it feels, how it flies. It flies just like a normal FPV system. The latency isn't great, obviously, and it's clear the low-level image detail is an issue on this. If we come in and have a look at how it looks around water, I always like to test my systems on how it looks over water. Yeah, it can't deliver the detail. If you've seen my other videos of DJI 04, oh, it's so windy. That does a much better job over this high frequency repeating detail. But I've got confidence in this. I'm happy to fly it low. I'm going to be careful. But we can fly it low level over the sand. It's fine. It feels fine. It feels, again, I've said this a few times, but a lot like the V1 system. It's really that simple. I really don't think it's ideal for freestyle, and close quarters, it is blocking a lot there as we fly up and look at the trees and the shadows. Yeah, it's definitely struggling with that. I've got to be careful because I'm going to go behind the VRX in a minute. And you can see the bitrate drop in there. We'll come up now, up that other side and see how it looks. I'm actually side on to the VRX here, which isn't ideal. Yeah. It's definitely struggling on that. Let's follow the water down. Yeah, it just... Wind and latency is definitely a bit of a factor. Yeah, it can't deliver in this situation. That's all mush. But when we start pushing it high level, I'm just going to turn my back to the wind a bit. The advantage of this is I can turn my back and the VRX module's on a cable. But when you start looking at the higher detail, so if we come over the trees over here, looking side onto the wind, yeah, it's okay. And then bring it up and bring the height in. It starts to look really good at height. It really does look very good at height. If you're a fixed wing user, I think you're going to like this a lot. Maybe a long range flyer, but not a long range flyer that's going to want to mountain cruise or anything like that. As you've seen, once you start mountain cruising and getting into that detail, just keeping an eye on the battery level. I think it's probably time to change back. But once you get into that lower stuff, it does start to mush up. Yeah, it lacks the detail. It comes back slowly. They could definitely tweak this more. But I wouldn't do this with the other systems. I just wouldn't. Now, I have spent a bunch more time playing and just trying to get to grips and understand how this system performs. And overall, everything that I've shown you in these two videos pretty much represents how the system performs in everyday real-world use. It looks lovely at high level. It really struggles with high-frequency detail. It does start to mush up very, very quickly. There is no focus mode on this or anything like that that we have on DJI, but it absolutely is flyable, and as I've said, for a fixed wing, I think it's going to be very, very interesting. Now, I have also been doing tons of tests with regards to how it behaves around signal loss, and I just want to demonstrate this here for you. It does have very fast signal loss recovery, but it does also fall off very, very quickly, as you have seen there. You get down to sort of 20 megabits, and it will fall off very, very fast. The image just stops. However, if you get your aircraft back in signal, it will come back almost instantly. Just to show you this here in slow motion, you can see it gets down to 21, 22 megabits, and suddenly it falls off. It seems to stop around 5 megabits a second on their readout, and then it just completely blocks, completely breaks. But if you then are able to get the signal back in view. I was actually moving out of line of sight there. It will reconnect pretty much instantly. In fact, it reconnects quicker than DJI in most cases. Now, I'm at the field to test the T3 system in low light and darkness. Now, I've just come here now. You can see the light level isn't too bad. It's not black yet. It's obviously going to start dropping. So what I'm going to do is get myself set up. We'll do some tests on this camera in this light level, and then we'll wait for the light level to drop down and see how those starlight features actually perform. Okay, so on this first flight, let's just give it a look at how it looks as the light level is coming down. I have to say, through the goggles, it still looks quite light. It really looks like it's the middle of the day, if I'm honest. It certainly doesn't look like the light level that I'm seeing with my own eyes. I'm just coming over here because I did just see a dog in the middle of the field randomly. Okay, so that looks pretty good at the moment. Let's just punch it up a little bit just so you can see what it looks like at height. That looks fine. I think I'm going to bring it back in and wait a little bit longer, because right now this looks and feels like I'm flying in the middle of the daytime. So this is a little bit pointless. So let's bring it back in and we'll give it a few minutes and try again. So let's go for flight number 2. Now, as I've said, it has got dramatically darker here. Now, you are starting to see that noise appear in the image as a result of it. I'm using the Starlight 1 setting. I haven't tried on the other Starlight settings yet. I'm just going to show you what it looks like over there. There's people walking there. We'll head over here out of the way. Let's just have a look at how it looks over here. You can see the lights there. Head through. Oh, I started to lose signal. It's actually because I'm behind the VRX module. I need to turn the VRX around if I want to go behind there. Okay, that's something to learn. I was right behind it then. Let's have a look at how it looks in the bushes. Do you know what? That doesn't look too bad. There's not... You can still see in the trees fine. I'm pretty impressed with that, considering we are talking that the light level is dropping down. There's a lot more mush in the image at this point. It's absolutely flyable. No issues with this at all. Pretty happy with that in the grand scheme of things. Plenty of detail in the trees, you know. It is mushing up, but it's fine. Absolutely fine. I'm intrigued to see what this looks like once the light level really goes down. So it's got quite a bit darker now. I can't see into the bushes. I'm looking around, and if I look into the bushes, it's just black holes. There's a little bit of life left in this battery, so let's just take this one out for one more flight before I wait for complete darkness to give it a look. You can now see the difference. You're starting to see the light level has dropped. If I now go to the bushes, everything's looking a lot more like mush. You don't have that detail that we had earlier. Flyable. You're starting, though, to really drop off the detail at low level now. I don't think there's any question if this is a Starvis camera or not. It's clearly is. And I'm intrigued at the different Starvis settings, and we'll try that when it gets a bit darker. This battery is really nearly flat. So just to show you a bit of height, you can see there
yeah, now it's beginning to struggle. Now it's beginning to not be able to see detail. You can still see the properties with all the lights on though. That's all pretty good. Okay, so this flight was always going to be a short one. So let's bring it in. I'm going to swap the pack now. And then we'll wait for it to pretty much get dark and then we'll start again.
Just before I do this one last flight here, I just want to show you the light level has really dropped now. You can still see there's a bit in the sky, but if I come back to the bushes, it's now getting quite dark. It's certainly not black, but I wouldn't usually fly beyond this point, and a normal camera is certainly not going to be showing us much at all. As you can see, we've got plenty of light on the quad. We've also got our lights on the Boxer as well with my illuminated gimbals. Always looks good, but the quad is lit up as well.
So now you can really see the detail is gone in the grass. You can see it, but it's all now mush. It's cleaned up a little bit there as I've come out into the field. This would absolutely be fine at high level. So if we just come up a little bit, there you can see what it looks like. Just giving you a bit of a view. There we go. From a fixed wing perspective, this would be fine. No problems at all. Just coming around. It just gets a little challenging when we start talking about this from a low level perspective and a detail perspective. You can see there we're coming down into the grass, but it's just a big mass. You can see the Boxer. That's how you can see me. What you're seeing lit up there. Oh, caught that out. Again, that's the problem with this. We got to the grass quicker than I realised. Let me get my bearings on the altitude. I think what we'll do is we'll bring it in and we'll just try the other starlight setting and see how it looks. Let's go into the menu and let's just have a look at these other starlight settings that are on the camera. We've got starlight ×1, ×2, ×4, ×8. And I am not seeing that is making any difference at all. We've got colour mode. Oh, that's interesting. Standard, cinema, contrast. Contrast looked pretty good then. Look at the additional detail in that. Okay. Okay, we're going to put it in contrast. Don't know how much difference the electronic filter is going to make. You can see the colour shifting as I'm doing that. Okay, let's turn this Ultra Starlight on to 8 and we'll have the contrast colour mode. I have no idea what difference that will make, but let's give it a shot. Just to give you perspective, it's pretty much black here now. Yeah, that's not really helped a great deal. Yeah, the grass is just a mush. You can absolutely see. I've got no, though, idea of how close I am to the ground at this. Again, I'll just put a little altitude on so you guys can see how that looks. It's definitely a starlight camera, that's for sure. It's definitely usable. It's not, though, a complete night camera. It's certainly this is its limit. You really wouldn't want to go beyond this. You can see stuff, but from a quad perspective, you certainly wouldn't want to go beyond this. If I just take it out over the trees over here. Again, we're struggling. Yeah, there's just no detail there on the trees now. Completely gone. It's just noise. So that's the limit. Let's bring it in. Just to show you what the light level was like when I landed there, I've obviously got the quad here lit up, but if I just put that down, you can see there, it's got really dark now. It's not black, I can see my hand in front of my face, but you know, the reality is that's as low as you're going to be able to go with the camera. You could absolutely fly it in a fixed wing situation, but for quads, that's pretty much going to be it.
Next, we're going to do the teardown. Now, in this, we're going to take the VRX apart, the VTX apart. We'll have a look at it, and I'll give you an overview then up on screen of what we find. Now, on the VRX, there are 4 screws on the back, fairly straightforward to get to. They're nice and visible. They just screw into the plastic. We'll undo these. This will then allow us to be able to pop off the back cover. Pop them out. Here we go. That then will allow the back cover to pop off. There is a security screw. That then shows you inside our main PCB as well as the built-in battery. This PCB, if I just flip it out, has 2 antenna connections that head off to our RPSMAs. If I just fold that back like that, there you can see we have a single PCB. There is a shield on that side covering the whole back, and then you've got 2 shields on this side. We've got one here with a fan which has been stuck to the middle, and then you can see our single battery soldered to our main connection there. Now, as for what the rating is on this cell, it is covered in foam. So it is a Samsung 21750S, so that's 5000 milliamp hour 21700 cell. So that's going to give you a good amount of use from this, but you can power it externally as well. With regards to looking at this PCB in a bit more detail, I'm not going to do it as a teardown here. What we'll do is hop over to some images that I've already taken to give you an overview of what we find below. Looking at this side of the board a bit closer, now you will notice that I haven't removed the shielding off the top of the Wi-Fi card. The reason for that is it's actually soldered in place. I don't want to damage it before doing all of my testing. However, we do know what chipset is under there. It is the Realtek 8812 EU. It is not the AU version, the EU version. That's what they've installed on both the air side as well as the ground side on the board. Looking around the rest of it, we have some voltage regulation over this side here, and then over this side you will find under this can that was here a Bluetooth chipset. That is this one here. You can actually see the antenna for it up here. There's a trace that goes along to there, down to there, and then over to this pin here. It took me a while to actually try and identify this, and whilst I haven't been able to find the exact model of this chipset, we do know it is a Bluetooth low energy chipset. They actually state it here, but I have also identified it compared to some other models, and then we've got some additional power regulation over here. Looking around the rest of this side of the board, you've then got a FET over here on the battery input. You can see that it is directly soldered to the board. There is some V-in and ground pads over here as well alongside our buttons, but really on this side of the board what you have is your Wi-Fi card. This is an external card that's been soldered on. This is exactly the same as the ones that you can see you can buy on the likes of AliExpress and others. The only difference is this one doesn't have the connector for the ribbon cable. This one is only direct solder, and then we've got the Bluetooth over here. Moving over to the other side of the board, in the middle you can see the main chipset. Now this is labelled the NF8128. We believe this is a SigmaStar SSR621Q, which is an NVR chipset designed for CCTV. Makes sense, it's got some A7 ARM cores, video encoding, decoding capabilities, I/O, pretty much everything you need to be able to run Linux and decode video on the fly. very similar to the kind of chipsets used by OpenIPC and others as well. It's not exactly the same chipset, but it actually makes complete sense. Then next to this, you've got your WinBond flash chip. And then over here, we've got a HDMI to DisplayPort adapter. What's quite interesting about this is it appears that the main chipset is outputting on HDMI and they're converting it into USB-C DisplayPort. Rather than passing HDMI directly out, they're actually doing a conversion over to DisplayPort, and that's why you can use it with USB-C or HDMI. It might have been a bit easier, in my opinion, to just have had a direct HDMI connection. We've then got some power regulation over here, as well as some more power regulation and I/O over there. The very basics are, though, it is very similar to a Redaxa or the other devices from Runcam. We've got a chipset that runs Linux, handles the video encoding, decoding, and then you've got your I/O. Next, moving over to the VTX and camera. So again, this is held together with some screws. You can see them there in each corner. So we're just going to undo these. It is a single PCB VTX. There's no dual board here, so everything is on the one side. If I then just carefully pop off the bottom heatsink, and you can then see we've got another big shield there with our MIPI connection. And then if we pop this side off, it is held in place with a bit of thermal compound, but it will release once you give it a bit of a tug. There we go. You can then see the antenna connectors have come off with it. And there we have our RF module, as well as our other connections there as well. And then if I spin over the other side, I've already moved this little shield, and there you can see the main chipset. This again is a SigmaStar chipset. I'll get it a bit closer under the microscope so you can see it in a minute. That's there in the center. We've then got our flash chip, our WinBond chip, our SD card slot, and then our power regulation. So looking at the VTX in a bit more detail, you can see there that SigmaStar SSC chipset. It is the 378DE. This is a bit of a newer one compared to what we've seen in the likes of OpenIPC. This is where some of the comments around AI is coming from with regards to this system. When you read the marketing material around this, there is wording around AI from SigmaStar. What I can tell you is, looking here, is that there is nothing specific with regards to AI built into this, and it's simply some of this branding that is used by manufacturers around their chipsets, and I suspect it is entirely based on this. Then we've got our flash chip, and the rest of this is pretty much just power regulation. Hopping over to the other side, and I actually made a mistake earlier. I said I couldn't show you the chipset because the cover was soldered on. It actually isn't soldered on. I thought it was soldered on. I double checked again, and then I found it does actually come off. So here you can now properly see the Wi-Fi chipset. It is the Realtek chipset. We'll look at it a bit more in a second, but that is it there. You can then see heading out to the amplifiers, the PAs there, and then heading out to our antenna connections. And then again, it looks like we've got some voltage regulation here down the bottom. If I just zoom out and hop over to this image, this will show you in a bit more detail the model number. You can see there it is the RTL 8812EU, as I specified earlier. And again, this is just one of those standard Wi-Fi adapters. Now, the final thing we want to have a quick look at is the camera. So I'm just going to undo the screws on the back cover. I haven't even seen this myself at this point, so I'm not sure what to expect. Sometimes when I've done a teardown on something, I have had a bit of a look first. However, in this case, I can say to you that I haven't. That's rather interesting. It looks like when I'm undoing that the lens and the sensor is coming away at the front. Yes, it is. So you can see that the camera sensor has come out from there. We've got our IR filter in there. What I'm going to do is just try and pop that back on and see if we can then remove the back cover, because that's the one I'm really interested in. Oh, there we go. Interesting. I'm actually seeing 2 PCBs here. DJI, please take note, if you're going to use an interposer on the back of the camera board, that is how you do it. So in here we have our MIPI connection. We have what looks to be an interposer board, which is soldered on. And then there's a couple of components underneath. There isn't a lot, but it does look to be an IC there. Now, that is soldered, so I'm not going to be able to show you that. But you can see that camera board there. And again, I just carefully pop that off. You can see the sensor there as well. Quite a large sensor on this. There's something on the bottom of that. I don't know what it is. And I'm not going to be able to tell you what it is, but there is definitely something there. And then the MIPI cable is glued into the back. I have to say, overall, the product is put together quite well. There's really no complaints about the quality of the hardware. It really has been very well done. So, yeah, that's our camera module. Now, before we wrap this up, I want to talk about a few extra features that this system has that I haven't tested. We have Ethernet pass-through, we have head tracking, and we have RC pass-through. Now, with regards to RC pass-through, I'm not going to test it. I don't recommend you use it. It looks like there is a serial S-bus output on the VTX, and they do say that there's an RC S-bus port on this, although they've labelled it RC output. In theory, it will pass the RC link over the air. I've not tried it. I would never recommend you fly with the RC link on board. Anyway, you should always have your own independent RC link for safety as well as redundancy purposes. Ethernet pass-through, I've not tested. I'm going to cover that in a future video. And the last one that I would have liked to have tested that I don't seem to be able to is head tracking, because the picture of the VTX shows that there's servo outputs. There's a yaw servo as well as a pitch servo on the VTX. However, there doesn't appear to be any head tracking input on this VRX module. They do have this port on the side alongside the Ethernet port, which also has that RC, what they call S-bus out, that has 5-volt servo power, it has ground, it has a serial input port and a serial output port. Now, it isn't clear if that serial input and output is the head tracking, because the VTX also has a serial input and output port. And as a result of that, I've not been able to test it. It is something I would have liked to have tested, because head tracking is something people are definitely going to be interested in. I'm going to have a bit more of a play with that, and I'll follow up in a different video if I manage to ever get that working. I think these guys need to get a bit more documentation out on that functionality, because I've not seen anything on the manual around that at all. Something else I just want to quickly mention is about Wi-Fi streaming, because this device is meant to have Wi-Fi streaming built in, and I will talk about this a bit more in a minute. However, I can't get it to work. My device doesn't transmit on Wi-Fi. I cannot connect to it on a smartphone. I have no way on this of turning that on and off. I don't know if it's a future feature that is coming. However, whilst it is listed in the marketing material, it isn't a feature I've been able to get to work. So right now, the only way that I found to get video out of this is via that USB-C, which is then either to a smart device or USB-C to HDMI conversion. As you've seen from the flight footage, the system actually performs quite well. However, there are some things we need to talk about around the bitrate that you saw up in the corner, the camera sensor that I mentioned earlier, as well as the marketing materials. Now, in the marketing materials on the website, there are several things that are what I'm going to call questionable. As I have mentioned already, we have the situation with the camera. Down here, they say that it is using a Sony Starvis 2 sensor. In the sort of reverse engineering and understanding of the system, we know there are drivers for the IMX662, which is a Starvis 2 sensor, but there's also a driver for the IMX307, which is a Starvis sensor, not a Starvis 2. Now, the reverse engineering or hacking that people have done fully suggests that this system is using the IMX 307, not the 662, which would imply that this marketing material is incorrect. There are definitely drivers for 662, but the sensor in the system we've received doesn't appear to be the 662. Now, this isn't terrible. They are both the same size sensors. They are actually very, very similar sensors, although the 662 is a newer sensor, Starvis 2, higher megapixel count. But what it implies is things are not quite as what they're being said on the website. That in itself, though, isn't the only thing that doesn't add up, because also in the marketing material, we have these claims around AI imaging, where they talk about ISP third generation, and they go into some AI super resolution. Our advanced AI algorithm intelligently reconstructs image detail, transforming 1080p into nearly 2.7K or 4K clarity with lower bit rates than native 4K. Now, that is quite the statement. Nowhere in what I have seen does that image look as good as 4K. In fact, it doesn't look as good as 04. I think that is quite the exaggeration indeed on what is being said. With regards to this AI, this is all based around the marketing information on that chipset, the SigmaStar SSC378DE. There is some marketing stuff around this chipset having AI image enhancing. However, that is not taking a standard image from 1080p to 4K. Don't get me wrong, we are seeing a lot of AI stuff around image processing at the moment, especially on night cameras, which I'll talk about in an upcoming video. This is at best an exaggeration on what it is capable of doing. I'm not saying there isn't AI image generation going on in the ISP, because we are seeing this across the board now from many ISPs. But to say it is pushing it into 2.7K or 4K, and they do have an out here, which is nearly 2.7K or 4K. Well, wait a minute. 4K is dramatically more than 2.7K. Again, it adds up into something that really does question how accurate this marketing material is. The final thing I also then want to mention is around the bitrate of 120 megabits a second. Now, there is no question that they are telling us it is capable of 120 megabits a second. And in fact, when you look at the playback in your footage, this is recorded on my DVR. I'm seeing 116, 117 megabits a second, 120 on their OSD readout, which then quickly drops down to 70. However, I find it extremely hard to believe that the actual data rate of the link, the video information being passed over the link, is at this bit rate. Now, there is no question that Wi-Fi isn't capable of delivering these kind of bit rates over even 20 megahertz carriers. However, that isn't actual throughput of video data through the link. On the likes of DJI and Avatar HD, we're used to seeing 40 megabits a second, 60 megabits a second. However, these are stating up to 120 megabits a second, and you do see that when you first take off on the display, but it does quickly drop down. Now, I suspect, we don't know for sure, that they're showing theoretical link throughput numbers, or at least some form of data rate that they're getting through the link, but that isn't actual video encoded information through the link. As shown in the teardown, the actual chipset being used in the RF front end is the RTL8812EU. It's a standard Wi-Fi adapter. Whilst they may be controlling it at the PHY level, that doesn't mean you're going to get this level of bitrate. This number that they're talking about is likely coming from the actual documentation from Realtek. It has a theoretical maximum bandwidth available depending on modes. They state here that the maximum PHY data rate is up to 173.3 megabits a second in 20 megahertz carrier mode, but this is maximum PHY data rate, not the actual link's data rate. There is a fundamental difference here. This is actually a theoretical number and not a real life number of how much data is being moved over the link. And you shouldn't think that the fact that this is showing a bigger number will mean it is better than the likes of DJI or Avatar HD. The reality here is they are likely showing different things, and you can see in the footage it isn't remotely as good as what DJI O4 Pro or even O3 looks like. This is decent, but it is not up to O3 or O4 level, and whatever they are pushing over it isn't the fully encoded video data rate, and as a result of that, it is somewhere between, in my opinion, the original FPV system and O3 with regards to image quality. Then we have this wireless mobile viewing feature that they say the system has. I can't get this to work at all. My system is not transmitting on Wi-Fi. There is no option to turn it on and off. I have no way of doing Wi-Fi streaming from this device as far as I can tell. Perhaps it's something that's going to be added in future firmware, but right now it certainly isn't there on my unit. In the end, there is a lot of fluff being said on the website. And honestly, right now, there is very little evidence to back a lot of this up. They also go on to talk about enterprise features, which there is no information on at all at the moment. The 3-in-1 data link, obviously the information on that. And there is, I'm not saying it's completely inaccurate because it isn't, but there is certainly a lot of guff here compared to what we're seeing in reality. Now, before I share with you my thoughts, I just want to mention that I recently made a video talking about the differences between all of the digital FPV systems. It talks about the difference between this, DJI, Avatar HD, HD0, but also in depth about the difference between this being based on Wi-Fi and the likes of Ruby FPV, OpenIPC, and anything else open source based on that as well. If you're interested in understanding a lot more around that, please do consider checking it out. I'll put a link to it in the description. It's a good one to watch if you want a bit more understanding of how this differs from a technical perspective to those other systems. Okay, so it's time for my thoughts on the T3. Now, this system is incredibly interesting. The baseline for me on Wi-Fi systems has been set quite low, and I have to say, this works incredibly well from the perspective of it looks and feels like a traditional FPV system. Yes, it's high latency, but it's like a high latency digital FPV system. What I mean by that is frame delivery is smooth, image quality is decent. You would not think you're in anything like the testing and stuff that I've done on OpenIPC, where I've still struggled to get consistent smooth frame delivery on these systems. The second I fly this, it feels like a normal FPV system, and that's really good. I like the image quality. I think it looks decent. The night image quality on that camera is good as well, as I've shown. The link stability is okay. It's got some quirks. As you've seen, it has the odd jitter here and there. It's very stable most of the time. You just might get the odd jitter. Its low signal performance is a little bit disconcerting. It is very much a cliff edge, so it's fine, 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 and then it's gone. There's nothing like focus mode like you have on DJI on this. It really does get to a point where it just hits a cliff. It's certainly not as smooth as even Avatar HD or DJI for that matter with the low signal behavior, but it does recover very, very quickly. From a FPV flight perspective, it does exactly what it says on the tin. However, it certainly isn't perfect. There are quirks in the software, there are quirks in the hardware, and then there's the price to talk about. When it comes to the software side of things, there are things here that need to be improved. It's a big shame that you don't have proper MSP DisplayPort. Yes, it takes MSP, but you don't have MSP DisplayPort OSD like you have on the other systems. You can't set the fonts, you can't have your full usual options. The software also is quirky. It's based around that sort of Wi-Fi controls. It's quite confusing. Multiple different power options for different frequency bands. All of that needs tidying up into being more like what we have in our traditional systems. Also, some of the options don't seem to do anything, which is a bit weird. So again, you've got some functionality there that isn't great. With regards to the hardware, I like the VTX. Very good size, like the camera, quite big, but fits my frame fine. I like the image quality from the camera, although, as I did mention, my DVR on my VTX is dead. I cannot get it to work. I have no idea why it stopped. It literally worked when I first got it, and that was it. So reliability remains to be seen. The biggest quirks for me on the hardware, though, are on the ground station, because I really don't know what to make of this. It's a weird device in the sense of it's not a goggles unit. It's too big and heavy to put on a goggles because of that built-in battery. It doesn't have a tripod mount on it. There's some screws in the back, but there's nothing for a tripod. I ended up sitting it on the floor. You can connect to goggles, but it's USB-C, not HDMI. Then you've got to use an adapter cable, which certainly isn't helping with the latency. It does somewhat make sense for a ground station, but it's not really set up in such a way that does 100% make sense for that, because you've got no tripod mount. You're going to need to make a holder for it. There are bits of this that feel unfinished. It really, whilst works with goggles, isn't designed for goggles. And I found that experience quite difficult to use. You've got a big cable coming down the side to the floor, or your tripod, what you tape this to. So I think they need to work on that. Also, there's some confusion over the I/O on this as well. Although I do want to say the built-in battery is quite handy. That is something I will give a positive for. From a system perspective, as I've said, the words I would use is incredibly interesting. And I could absolutely see people being really happy with this in a fixed wing situation. Maybe a long range quad, maybe. Most lately, fixed wing, ground-based scenario, water-based scenario. Something like that is where this seems to have its home. It certainly isn't designed for freestyle racing or anything like that. I think you have to give a huge amount of credit to them for delivering a system that works as well as it does, even though it's got the quirks that it's got. Then we have all of the murky stuff around the marketing materials. We have this AI imaging stuff, the claims of near 4K super resolution. I think that's an exaggeration at best. You've got this bitrate stuff, 120 megabits a second. There's all of this other stuff around the camera. You've got this pro-grade camera calibration. There's this talk around this flexible spectrum sharing with all of this co-multi-channel stuff around this pro functionality. I haven't seen any evidence to suggest this is happening. And there is just a huge amount of renders and marketing speak here that very little seems to bear out in reality. There's a huge amount of promises, a huge amount of marketing. However, it all seems to be renders and very little of it seems to be real. Now, as for would I recommend this, that's where things get a bit complicated, because there is one big factor here we have to take into account, and that is price. As I showed earlier, this kit with the receiver and VTX is available for $329 when in stock. However, if you look on Cadex, you can get the Cadex Avatar HD VRX module with the Avatar HD kit version 2 dual antenna VTX for $335. It is a very, very similar price point. And there is no way I can recommend this over Avatar HD. With Avatar, you can get your VRX module, which has HDMI output directly. You can use it with all of the same goggles as you could use this, but you can then choose a number of different VTXs and cameras because they've got that ecosystem built up already. But with Avatar HD, you also can go and get yourself a set of FPV goggles, either the Goggles X or the original ones, and then have a full goggle experience without having to have a VRX module. Add on top of that, you then have a system that has low latency, because Avatar will literally have half of the latency that this system has, which means whereas this is going to be relegated into sort of fixed wing, long range only, Avatar can do long range, Avatar can do fixed wing, Avatar can do freestyle. Having said all of that though, I should add that there are for some people scenarios that this would make more sense than Avatar. People flying Ardra Pilot who want Mavlink support, it does apparently have that Ethernet pass-through option as well, which may be useful, especially if you're building a larger fixed-wing aircraft with some of the big pan and tilt zoom cameras. There are elements of this that you don't have on Avatar, and I should highlight that. But from a general FPV perspective, when you line the two up side by side at the same price point, there's no world where I can really say this is a better option over Avatar HD. For me, the price puts this more than anything in a very difficult position. If it was $60, $80, $100 less than Avatar HD, then it would actually be a bit of a no-brainer. But at a very similar price point, for me, Avatar HD just wins every time. I have to say though, incredibly interesting. Something new. It works quite well. There are people who will be interested in this, so hopefully the information I've given you here will be helpful. If it has, please do let me know down below. If you have any questions, put it down there and I will try and answer them as well. And really, that's it from me on the T3 for now. If you'd like to support the channel to allow us to keep making content like this, I just want to say please consider checking out the links to my Patreon as well as Buy Me a Coffee. It's only through the support of my patrons I'm able to keep making content on this channel. If you'd like to support us, the links are down below. I want to say a huge thank you to all of my patrons, all of the donations. We would not be able to do this without your support. That's it. Let me know what you think. Look after yourselves. Stay safe. I will speak to you soon.